Hey, and welcome. Have you ever thought about how a program actually decides what to do? By default, code just runs straight down, top to bottom, one line after another. But today, we're going to change that. We're going to give our code, well, a brain. We're diving into something called control flow, which is basically the set of tools that lets our programs make decisions and repeat actions. This is how we go from simple scripts to some really smart applications.
And that really leads us to the big question, right? How do we take a basic script, one that just blindly follows a list of commands, and turn it into something that can actually react, choose different paths, and adapt? Well, that's exactly what we're going to unlock together.
Okay, so here's our game plan. First, we'll talk about what it means for code to think. Then we'll get into the nitty-gritty of making decisions with if statements and how to repeat actions using loops. After that, we'll cover some pro tips for mastering those loops. And finally, we'll see how it all comes together to make your code way, way smarter. All right, let's jump right in. Like we said, code normally just runs in a straight line. But the really interesting problems, they require us to break out of that line. And that's where control flow comes in. So what is control flow, really? Honestly, the best way to think about it is like one of those choose-your-own-adventure books, but for your code. Instead of just reading from page 1 to the very end, your program gets to a point and goes, if this happens, I'll jump to page 50. If something else happens, I'll go to page 82. It's this ability to branch out and make choices that is the absolute game changer. It's what lets our code stop just doing things and start, thinking. Okay, on to our first major tool for making those decisions, the if statement. This is the fundamental building block of choice in pretty much all of programming. It's how we ask our code a simple yes or no question and then act based on the answer.
All right, check this out. It's super straightforward. We've got a variable temperature, and we set it to 30. Now here's the magic, the if statement. It asks the question, is the temperature greater than 25? Since 30 is definitely greater than 25, that condition is true. And because it's true, the code that's indented right underneath it gets to run. Boom, it's a hot day. It's that simple. Now, if the temperature was, say, 20, Python would check, see it's false, and just skip right over that print line. Nothing would happen.
But what if you want something to happen when the condition is false? We don't want our code to just do nothing, right? That's where else comes into the picture. So here, the temperature is 18. Python asks, is 18 greater than 25? Nope. The if part fails, so the code just skips that first block and jumps directly down to the else part, printing, it's a cool day. It's literally a fork in the road for your code. One path if it's true, and another if it's false. Okay, but let's be real. Life is rarely a simple yes or no. A lot of the time you have multiple possibilities. And for that, we have Elif, which is just a shorter way of saying else if. Now, Python goes through this like a checklist, from top to bottom. In this case, temperature is 22. So first it asks, is it greater than 30? Nope. Okay, next check. Elif, is it greater than 20? Yes, it is. So it prints perfect weather. And here's the crucial part. As soon as it finds a true condition, it's done. It runs that code and completely ignores the final else. It found its answer and moves on. But we can get even more sophisticated with our questions. Sometimes you need to check multiple things at once. That's where logical operators come in. With and, both conditions have to be true for the whole thing to be true. You can't just have one. So age greater than 30 and income greater than 40,000. Both have to hit. Then there's not, which is awesome because it just flips the whole thing on its head. So if not logged in is a really clean, really easy way to say, hey, if the user isn't logged in, do this. It makes your code so much easier to read.
All right, so our code can make decisions. That's huge. But what about when we need to do the same thing over and over and over again? You're not going to copy and paste the same line of code 100 times, right? Of course not. That's where we bring in the loops.
So first up, we have the for loop. I want you to think of this as an assembly line for your data. We have this list of fruits. The for loop grabs the very first item, apple, puts it in the fruit variable, and then runs the code inside, in this case, print fruit. Then it goes back to the start of the line, grabs the next item, banana, puts that in the fruit variable, and prints it. It just keeps doing this, one by one, until it's gone through every single item in the list. It's incredibly efficient. Now, the while loop works a little differently. Instead of going through a list, it just keeps running while a certain condition is true. Here, the condition is while count less than 3. As long as that's true, it'll keep doing. Inside, we print the count. And then we get to the most critical line in this whole block. Count plus equals 1. We are changing the value we're checking. You have to do this. If you forgot that line, count would stay at 0 forever. The condition would be true forever, and you'd be stuck in an infinite loop. Trust me, you don't want that. So, what if you don't have a list? What if you just want to do something, I don't know, 5 times? You could make a list, like 0, 1, 2, 3, 4, but that's kind of clumsy. That is exactly why the range function exists. It's a super convenient shortcut. When you write 4, I in range 5, Python just knows you mean do this loop 5 times, with the variable I taking on the values 0, then 1, 2, 3, and 4. It's pretty much the perfect sidekick for the for loop. Okay, we've got the basics down. Now let's kick it up a notch. We're going to look at a few advanced techniques that let you gain really precise, fine-grained control over how your loops behave.
This is such a great way to understand these two. Think about listening to a music playlist. Continue is your skip track button. Let's say you're in a loop and you hit a value you don't care about. You just say continue, and the loop immediately skips the rest of the code for that specific item and jumps to the start of the next one. Break, on the other hand, is the stop button. The music's over. The second Python hits a break statement, the entire loop terminates, right then and there. It doesn't matter if there are 1,000 items left in the list. It's done. 2 incredibly powerful keywords.
Now, this one can seem a little tricky at first, but it's super powerful. Nested loops. It is literally just a loop inside of another loop. The clock analogy is perfect here. Think of the outer loop as the hour hand and the inner loop as the minute hand. For every single time the hour hand moves once, the minute hand has to do its entire full rotation. The outer loop variable I starts at 0 and just stays there while the inner loop, for j, runs completely, 0, 1, 2. Then, and only then, does I finally tick over to 1 and the whole inner loop starts again from scratch. Okay, so this happens all the time. You're looping through a list, but you don't just need the item itself, you also need to know its position, its index. You could set up a manual counter variable, but that's messy. Instead, Python gives us enumerate, and it is an absolute lifesaver. You just wrap your list in enumerate, and now on every single pass of the loop, it gives you 2 things, the index and the value. 0 apple, 1 banana, 2 cherry. It's so clean. And for my last trick, zip. What happens when you have 2 lists that are related to each other? Like a list of names and a corresponding list of scores. How do you loop through them together? Well, zip is pure magic. The name is perfect. It works exactly like a zipper. It takes the first item from names and the first item from scores and zips them together into a pair. Then it takes the second from each and zips them. It's just an incredibly elegant and Pythonic way to handle parallel lists. All right, let's bring it all together. Think about where we started. We had a script that was, well, kind of dumb. It could only follow instructions in a straight line. But now we've given it the tools to analyze conditions, to choose different paths, and to perform repetitive tasks without getting tired. Our code is officially smarter. And this right here is the takeaway. This is the whole point. You've learned how to control the flow. You're not just writing a to-do list for a computer anymore. You're more like a conductor of an orchestra. Your code doesn't just run, it thinks, it chooses, and it repeats. It's become a dynamic, responsive thing. So I'm going to leave you with this final thought. Now that you know how to make your code think and repeat, the door has just swung wide open to a whole new world of problems you can solve. So the question is, what are you going to build? What problems are you going to solve with your new, smarter code? Thanks so much for watching.